All right, this is part 2, 9.5, mean absolute deviation, or the MAD, which describes your parents when you don't do your work. How do I find the mean absolute deviation of a data set? Okay, here's my data set. I made a list of how many trips each student has visited Disneyland. Number of times, I should have said. I don't know why that was so convoluted. The number of times each student's visited Disneyland in their entire life in my third period class. This was last year. One student said 4, the next student said 6, then 7, 3, 8, 1, 2, 0, 5, 4. You want to find the average difference between the data values and the mean. We want to find the mean absolute deviation, right? We want to find out on average how far are these data from the mean, because that will tell us its variation or how spread out the data are. Okay, to find the MAD, we just went over in the first video, there are 3 steps. The first step is pretty obvious. It's in the name. First, you find the mean. So a lot of students remember this step because it's not too bad. And so we're going to find the mean, and we're going to do that by adding all the data together, finding the sum, right, of all the data, and then dividing by how many data there are. And I'm just going to do this mostly in a calculator. Hopefully you don't mind. 4 plus 6, well, that's 10. Wait, 7 plus 3 is 10. So that's 10 plus 10. That's 20, right? 8 plus 1 plus, or no, sorry, 8 plus 2 is another 10. So that's 10, 20, 30, right? 31, 39. Wait a second, I didn't even need a calculator. Is that right? Did I do this right? 4 plus 6 is 10. 7 plus 3 is 10. 8 plus 2 is 10. That's 31. Plus 5 is 36. Oh, no, it's 40. See, this is why you check your work again. Wink, wink, nudge, nudge. See, you always check twice. Just like Santa Claus. Okay, 4 divided by how many data are there? There are 10. So it looks like our mean is 4. Sweet. Okay, the second step, the one that everybody goes, huh? I forgot how to do it. How do you do it? You make a table or a list of how far each data value is from the mean. Here's the mean. The mean is 4. So what we're going to do is we're going to go, how far is 4 from 4? 0. How far is 6 from 4? 2. How far is 7 from 4? 3. How far is 3 from 4? 1. Notice I'm only taking positive numbers. How far is 8 from 4? 4. How far is 4 from 4? 0. How far is 5 from 4? 1. How far is 0 from 4? 4. What the? How far is 2 from 4? 2. How far is 1 from 4? 3. I better check my work again. I wouldn't accidentally want to make a mistake. How far is 4 from 4? 0. How far is 6 from 4? 2. 7 from 4? 3. 3 from 4? 1. 8 from 4? 4. 4 from 4? 0. 5 from 4? 1. 0 from 4? 4. 2 from 4? 2. 1 from 4? 3. I'm just going to hope that's right. I'm just going to hope that's right. To fill in the table, think of how far you need to go from each data value. Sorry about these grammatical things. I meant to get rid of those. How far you need to go from each data value to the mean. So how far is finding the difference? So really you're subtracting. Whenever you find out how far something is, you're finding the difference. So you need to go from each data value to the mean. Okay, we did that. For example, look at the number 4 in the top left box of the table. How far is 4 away from your mean of 4? 4 is 0 away from 4. Okay, so now we have a list of how far each data value is from the mean, which makes sense. We're finding the mean absolute deviation. And I should go over this word deviation. Deviation means how far something is from normal. So 4 is considered our measure of center, that is the most normal. Then a deviation is how far are all of these numbers in our data set from normal. And as you can see, 4 is 0 away from normal, 4 is 0 away from normal, but these other numbers are away from 4. Okay, so last step. Now we have our list of deviations. Now we find the mean of our list of deviations in step 2. So I'm going to add all of these together. That's 0. That column 0. This column is 3. This column is 7. 3 plus 7 is 10. Plus 3 is 13. Plus 7 is 20. And I'm going to check my work twice. 0, that's 3. Plus 7, that's 10. Plus 3 is 13. Plus 7 is 20. And there are 10 data. So the mean absolute deviation is 2. What does that mean? It means that our data are pretty concentrated. There aren't really any outliers or anything that's going to make this mean absolute deviation be way different. So in other words, we have a pretty concentrated data set. If you look at this, all the numbers are pretty close to 4. I mean, no number is more than 4 away, and some numbers are 0 away. So really, it's pretty close. So the mean absolute deviation is 2, so we have very little deviation. And let's go over our kind of steps or notes and conclusion here. To find the mean absolute deviation, there are 3 steps. First, find the mean. I know usually I have you guys do this, but since it's just me, make a list or table of how far each data value is from the mean. This is your list of deviations. So use those clue words in mean absolute deviation to help you put together what those 3 steps are. Find the mean of your list of blanks you found in step 2, deviations. Okay. A deviation is the difference between the data value and the mean. Okay. And the next one, I'm going to scroll down. I'm going to finish this question. And then I'll do a third video for the last one. If the mean absolute deviation is relatively small, like ours, we had 2 in this first example, the data are not very spread out. They're not very spread out. This means that the data are closer together, so there's less variation. And I can hear you. You have this in your mind as you're going through this. That's great. Try to answer these questions before I answer them for you. You can even pause the video and go, I think that answer is this. Sorry, I'm having trouble with this thing. Okay, period. So good, if you can answer those questions. I'm going to pause or stop this video and do a part 3 for our last question down here. I'll be right back.